Today we will be discussing Chapter 2, Section 1, which is found on page 31 of your book. It is titled Scientific Methods. When you finish this section, you should be able to list and describe the steps of the experimental method, describe why a good hypothesis is not simply a guess, describe the two essential parts of a good experiment, describe how scientists study subjects in which experiments are not possible, and explain the importance of curiosity and imagination in science. I want you to look at this picture and take a moment to think about why might the scientist be measuring the wolf's tail. Once you have come up with a reason why, I want you to think about how might they use the information they collected. I'm going to give you a few seconds to enter this into your journal. One reason the scientists may be measuring the tail is to record characteristics of the members of the wolf pack. The scientists could use this information to study how the wolf pack changes over time. Scientists make most of their discoveries using the experimental method. This method consists of a series of steps that scientists worldwide use to identify and answer questions. Observations is the process of obtaining information by using the senses. Observing is the first step of the experimental method. Observations can take many forms, including descriptions, drawings, photographs, and measurements. In this course, you will be taking all of these types of observations. A hypothesis is a theory or explanation that is based on observations and that can be tested. This word basically means a possible solution to a problem based on knowledge and research. Forming a hypothesis is the second step of the experimental method. A hypothesis is not merely a guess. A good hypothesis should make logical sense and be based on what you already know about the situation. Predictions are statements made in advance that express the results that will be obtained from testing a hypothesis if the hypothesis is supported. The hypothesis is your general statement of how you think a scientific phenomena in question works. Your prediction lets you be a little more specific. A prediction is used to test a hypothesis. An important thing to remember during this stage of the scientific method is that once you develop a hypothesis and a prediction, you shouldn't change it, even if the results of your experiment shows that you are wrong. It's important that any hypothesis can be disproved. Remember, every time a hypothesis is disproved, the number of possible explanations for an observation is reduced. By eliminating possible explanations, a scientist can zero in on the best explanation. Experiments are procedures that are carried out under controlled conditions to discover, demonstrate, or test a fact, theory, or general truth. An experiment is performed when questions that arise from an observation cannot be answered with additional observations. Good experiments have two essential characteristics. A single variable is tested and a control is used. The variable is the factor that is changed in an experiment in order to test a hypothesis. To test for one variable, scientists usually study two groups or situations at one time, with the variable being the only difference between the two groups. The experimental group is the group in the experiment that is identical to the control group except for one factor, the factor you're testing, and is compared to the control group. The control group is the group in the experiment that serves as a standard of comparison with the experimental group. Data is any piece of information acquired through observations or experimentation. Graphs are often used by scientists to display relationships or trends in the data. Bar graphs are useful for comparing the data for several things in one graph. Organizing data into tables and graphic illustrations helps scientists analyze the data and explain the data clearly to others. Graphing the information makes the trends present in the table easier to see, as you can see in this slide. Scientists determine the results of their experiment by analyzing their data and comparing the outcome of their experiment with their prediction. Ideally, this comparison provides the scientists with an obvious conclusion. Often, the conclusion is not obvious. In these cases, scientists often use mathematical tools to help them determine whether the differences are meaningful or just coincidences. We will go into more information about the different mathematical tools used later in this lesson. Scientists often repeat their experiments. The more often an experiment can be repeated with the same results in different places and by different people, the more sure scientists become of the reliability of their conclusion. Scientists look for a large amount of supporting evidence before they will accept a hypothesis. Scientists publish their results, sometimes in scientific articles, to share what they have learned with other scientists. Scientific articles include the question the scientists explored, the reasons why the question is important, background information, a precise description of how the work was done, the data collected, and the scientist's interpretation of the data. When the use of experiments to answer questions is impossible or unethical, scientists test predictions by examining correlations. Correlation is the linear dependence between two variables. This picture shows a correlation between sales and shaved heads. Do you think this is a very strong correlation? A better example of correlation is a ring on a tree trunk. The relative width of a ring on a tree trunk is a good indicator of the amount of rainfall the tree received in a given year. Trees produce wide rings in rainy years and narrow rings in dry years. This method was used to help scientists investigate why settlers at Roanoke Island all died and why many died at the Jamestown colony. The scientists concluded that settlers may have just been victims of unfortunate timing. Although correlation studies are useful, they do not necessarily prove cause and effect relationships between two variables. Scientists become more sure about their conclusions only if they find the same correlation in different places. Good scientists tend to share several key habits of mind, or ways of approaching and thinking about things. The first habit of mind is curiosity. Good scientists are endlessly curious, which drives them to observe and experiment. The second habit of mind is skepticism. This means that good scientists don't believe everything they are told. It must be tested and proven. The third habit of mind is openness to new ideas. Good scientists keep an open mind to how the world works. A lot of times, an open mind will lead to new discoveries. Another habit of mind is intellectual honesty. A good scientist is willing to recognize and report the results of an experiment, even though it may mean that his or her hypothesis was wrong. Lastly, good scientists share imagination and creativity. They are not only open to new ideas, but able to conceive new ideas themselves. They have the ability to see patterns where others do not, or can imagine things that others cannot. This allows for good scientists to expand the boundaries we know. An example being when John Snow created a spot map which effectively pinpointed the source of a cholera epidemic in 1854.